Welcome to a potentially profitable video. Let's take a look at how much money you make in a year depending on how many math classes that have been taken algebra and above. So this shows a set of data points from different people and how much money they make. We can see it looks a lot like a positive correlation. Now, when I say correlation, I don't mean necessarily that it's causing it. Oftentimes, scientists use this to prove things, but there should be more research done. For example, the students who take higher math level classes probably are also from higher income families, have more access to those math classes. So not necessarily taking lots and lots of math classes will cause you to earn that income, but people who have taken those math classes, it correlates with the amount of annual income. So if we draw the line of best fit, the best we can, and we're just using the eyeball method, there are more exact methods, we can take a look at this. Now we can calculate the slope by finding 2 points on that line. So I want to look to where I can find the exact value of those points. So right here looks like a good value, and then looking up there, seeing where that line is actually touching that cross section right there. This looks like a good one. So when I have those 2 points, I can use those to calculate the slope. And I do that by finding the change in y over the change in x. So if I draw this, I can use delta y to figure that out. And if I count up here, I have to realize that each one of these represents actually $10,000. So that's a total of 80. Now let's look at the change in x. So I can draw it over here. I can count that. Now each one of these actually represents a half or 0.5. So I'm starting over here at 3.5 and I'm going all the way to 8. So let's take a look at what that makes the change in x. That's a total of 9 spaces. But those 9 spaces, each one's a half, so that is 4.5. Now I can calculate my slope. My slope equals the change in y, which is 80, over the change in x, which is 4.5. And if I use a calculator, that equals 17.78. Now notice I used little wavy lines. That's because I rounded. That's approximately equal to that. Now if I rounded even more, that's approximately equal to 18. And when we talk about 18, we really mean $18,000. And that's really meaning that there's $18,000 per math class, algebra and above. So that's my rate. Now I can use this information to help me write an equation for the line. We know in slope-intercept form y equals mx plus b. Well, this is my slope or my rate. That's going to go in for m. Now what's my y-intercept? Well, let's take a look at our line. So if I look over here on the y-axis, I can see it intersects the y-axis at 20. So if I have 0 classes higher than algebra or algebra above, $20,000. So that's approximately equal to, it's not quite 20. Let's say 16. So now I can plug that into my equation. Y equals 18, because remember it's measured in thousands, x plus 16. So now we have an equation that relates the number of higher level math classes, x, with the annual income in thousands. Now we can use that to predict. Let's say we took 3 math classes. Let's look at maybe what the annual income would possibly be. So y equals 18 times 3, that's the number of math classes, plus 16. We'll do the math here, 18 times 3 plus 16, and that gives us 70. So that's $70,000. So we can use this line to predict the annual income by plugging in a value for x and figuring out what the income is. Now let's take a look at collecting data. So if we're collecting data in order to make this line of best fit, let's say we have a drippy faucet and we're wanting to know with that drippy faucet, we're going to leave it overnight. We can't fix it and we're going to leave it overnight, and we want to know, do I need a pitcher, a bucket, or something even bigger? So let's take a look at how we can collect some data to make that prediction. And hopefully we're not going to need a whole swimming pool. Then we're in really big trouble. So we're going to get a graduated cylinder and we're going to use that to collect water over time. So we're going to measure how many minutes and how many milliliters are in that amount of time. And hopefully that will give us a rate, and we can use that to create a line and make a prediction. So let's say we wait 2 minutes, and in those 2 minutes, we have collected 5 milliliters. So we can use that as our coordinate point, 2, 5, our ordered pair. In 2 minutes, we collect 5 milliliters. We can graph that point. We can use that point to help calculate the slope if we have another point. Let's say we wait another 2 minutes, and in those 2 minutes, we collect 10. So that's a total of 10 milliliters. That's a total of 4 minutes, and we've collected 10 milliliters. Well, now let's say we kind of forgot, and we let some time go by. We actually let 10 minutes go by, a total of 10 minutes, so another 6 minutes. And we look at it again, and we find that there are 23 milliliters. So a total of 10 minutes, and we collect 23 milliliters. Now let's say we get distracted and we find something else to do, and another 10 minutes has gone by. So it's a total of 20 minutes, and we find that 49 milliliters are collected. Now notice the little meniscus at the bottom. That's how we measure it, the lowest point. The water's kind of sticking to the sides. So let's say some more time goes by, another 2 minutes goes by, and in those 2 minutes, so we've got a total of 22, we collect 56 milliliters. Now, our graduated cylinder only goes to 100, so we're going to kind of stop now and see if we can use this to help calculate. So we've got our coordinate points here, and we actually find the slope between 2 of those points. We know this is not an exact line, or probably not an exact line. Let's go ahead and calculate the slope though. The change in y over the change in x, and our change in y is going to be the second coordinate, the second y coordinate, minus our first point's y coordinate. Change in x is the second point's x coordinate minus the first x coordinate. So now we can do that calculation, and we have 5 over 2, or 2.5. Now what this means is we have 5 milliliters for every 2 minutes. So 5 milliliters for every 2 minutes. And that's our slope just between those 2 points. We can do another 2 points. We can try the next 0.2 and 0.3. So the y coordinate minus the other y coordinate over the x coordinate minus the other x coordinate. And that gives us 13 over 6. So 13 milliliters in 6 minutes. Now notice these slopes are not the same. They're not the same. They're similar, but they're not the same. And that's where we get our line of best fit, is we're really looking at the comparison between the slopes. We can take an average of these slopes if we take all of the coordinates. So let's take a look at our coordinates. Now we already did the first 2 points. We did the change in y over change in x. And we got 2.5. And we did the second coordinate and the third coordinate as well. We found that slope. And that's equal to about, that's our little wavy lines, about 2, and the rounding, 0.16. Now we can do the next 2 as well. Well, let's do 0.17. That's instead of truncating, we'll round there. Okay, so we're going to do 49 minus 23, that's our change in y, over our change in x, which is 20 minus 10. And that is equal to, calculating that, oh, let's go back and we'll write milliliters per minute so we know what those numbers really represent. And so we're going to do 49 minus 23, which is 26 over 10, and that's a nice easy one to do, and that is equal to 2.6 milliliters per minute. And we can calculate the other one as well. 56 minus 49, our y difference right there, change in y. 22 minus 20, 20, not 2. Let's fix that, 20. And that is equal to 2 on the bottom, 2 in our change in x, and our change in y is 7. So that's equal to 3.5 milliliters per minute. Now we're pretty close in there. We're between 1. But what we can do is now average these values to get an average slope. Oh, now I goofed a little bit here. I have those approximate signs where they really shouldn't be. So those are exactly equal to 2.5, 2.6, and 3.5. So that's just a little correction there, just so that you can see that. But let's go ahead and average this. Now remember, those other values are corrected to be exact values instead of those wavy lines. And when we average this, we're just going to take all of the values and divide by the number of values we have. So 2.5 plus 2.17 plus 2.6 plus 3.5, all over 4 because we have 4 values. And calculating that on a calculator, that's approximately equal to 2.6, and we're going to round it, 69. And that's milliliters per minute. Now that is our average slope with those values. I could actually calculate it in between other points too, like I could do 2,5 and 22,56. So I could get lots of values for my slope and then average it. I just did them between each 2 points. Now we can use this to write an equation. The slope-intercept form of an equation is y equals mx plus b. Well, what's the b going to be in this case? So the b is my y-intercept, and my y-intercept, remember, is when x is equal to 0, so at 0 minutes. Well, at 0 minutes, I'm going to have 0 milliliters because no time has passed, so no water has fallen. So b is equal to 0. So in this case, y equals my rate, which my rate is 2.69 x. And let's say what y is equal to. So y is going to equal the number of milliliters, and x equals the number of minutes that have gone by. And my y-intercept is 0. Now remember, what I really want to know is what's going to happen after 10 hours. Well, if we look at our x, it's measured in minutes. So really we have to change that 10 hours into minutes. So there's 60 minutes in an hour. So I have a total of 600 minutes I need to play with here. And I use that to go ahead and plug that into my equation that I created. And so y equals 2.69 times 600. And that's going to give us, I'm using a calculator for this one, that gives us y equals 1,614 milliliters. Now I know my pitcher holds 2 quarts, so I've got to look at a conversion between milliliters and quarts because my pitcher isn't measured in quarts. So let's take a look. I just looked this up on Google, and I found that 1 quart is equal to 946 milliliters. So my pitcher is 2 quarts, and so if I double that, my pitcher is going to be plenty big to hold 1,614 milliliters. Now let's go ahead and graph this on our line just so you can see how the line of best fit, when we're doing that and calculating the slope, fits in when we do those average slopes. So I'm going to go ahead and plot my ordered pairs, or my coordinate points, 2, 5, and notice my scale on here. So my scale is, each one of my y values is 5 milliliters, and each one of my x values is 1, and that's my number of minutes. And I'm going to go ahead and plot this. And as I plot these points, I'm seeing that positive correlation, which I would anticipate because my slope is positive, and it's a little more than 2.5. And okay, so here we go. Now notice it's not as steep because each of my y values represents a 5. It doesn't represent a 1 like my x value. So I've got them all plotted on here. And then I'm going to go ahead and draw the line of best fit here. And I can plot the point 0, 0 as well. So I'm going to start here with my line tool. And I'm just going to eyeball it. Remember, this isn't super exact, but I'm going to try to go through as many points and make that distance between the other points as small as possible. So I think it looks like about right here. Now, when I have this line, I can use it and calculate the slope just by finding 2 points on this line. Now remember, this is just my line of best fit. It doesn't necessarily correspond with the coordinate points I have there. And so I can look to see and find a point that goes through an exact value here. So as I look, this one, probably right here. This one looks pretty close at 19, comma 50, and then at 21, comma 55. So here's my coordinate points. I'm going to look over here, see what they are. That's 19, comma, and over here is 50. That's my first coordinate point. And my second coordinate point, remember I chose those coordinate points because they were exactly on that line. I didn't have to guess any fractions. So that's at 21, comma, and go over here and I get 55. Now I'm going to calculate the slope by doing the difference in y over the difference in x. So I have 55 minus 50, that's my change in y, over 21 minus 19. So I get 5 over 2. And that's approximately equal to 2.5. Now that's pretty close to the slope I calculated. So if I compare it to that 2.69, that's pretty close to my slope. Now remember that first slope I found from averaging the values, and the second slope I found was from looking at my line of best fit and calculating the slope from that. Now I'm going to change that approximate sign again to that equal sign. I goofed up a little bit there. And now you're ready to build some math muscles. Well, math can help you with your mental muscles. It can also help you with your physical muscles, too. Oh, this is heavy.